All right, our second video on solving equations by factoring. Here is an equation: x cubed equals x squared plus 6x. I want all three of these terms to be on one side. If we're going to solve an equation with x squareds and x cubes, we want everything set equal to 0. So when I do this, I will start by moving everything to the left. So that's going to say x cubed minus x squared minus 6x. And I say equals 0. I will subtract both terms from the right side, move them to the left. I now have a common factor of x, so I pull that factor out, and it leaves x squared. X squared divided by x is x. Minus 6x is going to be just minus 6 equals 0. So now I have on the inside of this, I'll look at just the inside. The xy I'll keep on the outside for now, and I'll be copying that down. So I have an x here. Since I have a plain x squared, I know that right away we're going to look at just these back factors, and we're going to break this out into two factors. And that I will put an x as a first term on each. Now I need the factors of negative 6. They give me a sum of negative 1. Those two factors are negative 3 and positive 2, because negative 3 plus 2 is negative 1. Okay, so we got that to take care of. I got to take care of my mistake here. Positive 2, and I set it equal to 0. I now have three factors equal to 0, so I now will have three answers. So I say x will equal 0, or x minus 3 has to equal 0, and I solve for x on that, and I say x can equal 3, or x plus 2 equals 0. When I subtract 2, I get x equals negative 2. So this is an equation. I'll have three answers. A big clue to that would tell you the 3 on the exponent here. That means you're going to have three answers to an equation. That's something you can take a look at as you're working through the work. All right, next example for you would be this one. If I have a 10-foot ladder is placed against a wall, so the bottom of the ladder is 6 feet from the bottom of the wall. How high from the ground is the top of the ladder? Tell me, what shape does this make? That's a triangle. There's a certain theorem that you need to remember to do this kind of a problem. I know it's a 10-foot ladder, so the 10 is out here. The 6 is from the bottom of the wall. And I need to know this height right here from the tip of the ladder to the ground. So that is my x. Now that theorem, in case you can't remember, is called the Pythagorean Theorem. And that Pythagorean Theorem says that a squared plus b squared equals c squared. And with the Pythagorean Theorem, you need to remember that a and b are the legs. This is where we put our lengths and our measurements for the legs, right here. Those are the shorter sides of the triangle. And your hypotenuse, your longest side, that's C. So as I look here, I have an A. I have one leg here because the legs, they form the right angle of the triangle. And the right angle is going to be the ground and the wall. So I would say 6 squared plus x squared, that's my legs, equals 10 squared. Okay, and now I'm going to just solve for x. I have 36 plus x squared equals 10 squared, which is 100. I'm going to get x by itself, so I'll subtract 36 from both sides. And I say x squared equals 64. And how do I find the answer when I'm supposed to find x squared? What number times itself? That means I do a square root. And I say the square root of x squared equals the square root of 64. So then x equals 8. So that means this side length over here it's 8 feet from the bottom of the ground to the top of the ladder. So if you have any questions on that, please bring it to me. The other way you may end up doing a Pythagorean theorem problem is you may actually be given both numbers for the legs and have to find the hypotenuse. And I believe you will probably see that somewhere in your work. If you need any help with that, let me know. I'm not going to do an example in the video just to keep the video, not get it from getting too long. All right, the last problem I want to do for you is a problem like this. You're trying to build, someone's trying to build a garden, and they have 352 square feet of rock for a border. So the border is out here, and the garden is here. Garden is 16 feet wide by 20 feet long. They want to put a rock border around the outside. So we have to figure out how to do this. Well, in other words, what you're trying to do, you've seen this kind of a problem before where they say find the area of the shaded region, and they shade the area around the outside out here. To do that, I'm going to have to find the area of the large rectangle, and I'm going to subtract off the area of the small rectangle to find this border area. So now how do we do that with this kind of a problem? All right, I'll show you. To start with, I need the area of the large rectangle. I have an X here for this width, and even though it's not written down here, the border will be the same width on the top as it will be on the bottom. So I have a length of X here and a length of X here. That means the width is equal to 2X plus 16. So I write 2X plus 16 and in parentheses. This is an area problem. Well, when you find area of a rectangle, that's length times width. So I've found the width, I need to find the length. So I'm going to put a parenthesis here. My length, I have an X over here because that's the distance from here to here. Now I have another 20 from here to here, and then also another X on the left side over here. So that also means there are 2X. And then I'm going to add the 20. Now that's the area of the large rectangle. I need to subtract the area of the small rectangle. Well, the area of the small rectangle is found by taking 16 times 20. So I'm going to take, and I'm going to subtract, and I got to do 16 times 20. What does that all equal? That equals my 352 feet of border. So quite a bit to set up there, but this is how you do it. You find the area of the large, subtract area of the small, tells you the area of the border. So now what do I do to find X? I have to do some work, all sorts of types of work here. The first thing is I'm going to FOIL, or I'm going to distribute this and multiply, which we did back early in chapter 5, in the middle of chapter 5. And then we're eventually going to do some factoring again. So when I multiply this, it's 4x squared. And then I'm going to do 2x times 20, so that is plus 40x. And then I have 16 times 2 is plus 32x. And then 16 times 20, that's plus 320. And then I'm going to say minus another 16 times 20, so that's minus 320. And that all equals 352. I know you're just looking at this going, oh my goodness, there's so much to write out here. Believe me, it's not that bad. You'll get it just fine. Combine your like terms. The 320s are going to cancel, and I'm going to put together the 40x and 32x. So I say 4x squared plus 72x. These cancel. 320 minus 320 is 0. That equals 352. I want all my terms on the one side to create a trinomial. 4x squared plus 72x. And I will subtract off 352 to set it equal to 0. Big numbers. Any common factors? Let's see, is there a common factor of 4? 352 divided by 4. So 352 divided by 4. Let's see here. Let me whip out that calculator real quick. And 352 divided by, where's it divided by button? There it is, divided by 4. Hey, 88. So that makes it a lot easier. All right, so I'm going to take out a factor of 4, and I'm going to leave behind x squared, and then plus, and 72 divided by 4 is 18x, and then I'm going to say minus 88, as we just found on the calculator, equals 0. Nice thing I've created here is I have no number in front of x squared, so that allows me to write it this way: 4 times parenthesis, 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 and I've got an x here and an x here, and now I need the factors of negative 88, They give me a sum of 18. So let's see what we can figure out here. I know a lot of us right away want to think of this one, a negative 11 and a positive 8, or a positive 11 and a negative 8, but we only get an answer of 3 here, and this is negative 3. So we're going to have to find something a little bigger. I have to find something a little bigger. My mind next goes to 22 and 4, because I think of 11. Well, what about 22? So I could use positive 22 and negative 4. And that gives me my sum of positive 18. So that tells me that in here I'm going to write plus 22, and I'm going to put minus 4. And that all equals 0. So now, how do I solve? I'm going to, the 4, I pay no attention to, and I say that x plus 22 equals 0, or x minus 4 equals 0. Well, x equals negative 22, or x equals 4. Now, as I look up here, this is an actual garden. I need an actual real width. There's an issue with one of the answers down here. The one that has the issue is right here. I can't use a negative 22. We can't have an actual width up here, say negative 22. So there's only one answer that works, is that x equals 4. That means the width of the border width will be, how wide can the border be? 4 feet. 4 feet. Okay, so there you go. The problems that I want you to do for this, let me type those in here for you real quick. Those come from page 324 is where it starts. And I believe there's some problems here that will actually go to 325, but problems 23, 24, 26, 73, 77, and 79. And when you finish these, turn these in. Turn in the last 2 assignments. So probably should pause the video here so you can get that written down and then go ahead and get to work.